Okay, so today we'll be doing the homework questions for lesson 15, I think it said on Shobi, in week 3, lesson 3, as we missed the second lesson. So, our homework questions today is chapter something, 16A and B, which are, as a screen, easy questions. There's Samuel Smith. So, for the first question, 16A. So, the first step I take in this question is for all of the powers of 0, so here and here, due to the index law of one of them, anything to the power 0 is equal to 1. We can immediately say that is equal to 1. Hello.
This is the third time he's messed up, sir.
And this is also equal to 1. So now we can just make those equal to 1. And there. And also, in the next step, I'll be removing these ones as they do not add anything to the equation. Or, not the equation, the expression, as there's no equal sign. So, now, the next step I take in this is to multiply the powers inside each of the brackets, so these three, by the powers outside their corresponding bracket. So, 5 times negative 3, this is also due to a different index 4. So 5 times negative 3 is negative 15. Due to negatives times positives equal negatives. So therefore, negative 3 times 5, negative 15. Divided by bracket due to this not being opened.
Press record.
Huh?
Never mind, keep going.
Wait.
I'm recording. Really.
Okay. So, and then negative 3 times negative 6 is equal to negative 18. Therefore, divide by negative 18 and negative 1 times negative 3. Now, this one's interesting. Due to it being two different negative numbers, if you actually take a negative number and multiply it by another negative number, it becomes...
Look at the camera, Vasili. Damn.
It becomes a positive number. I'm teaching the class, okay?
Yeah.
It becomes a positive number, and therefore that becomes times 2 to the power of 3, due to it being 1 times 3, but both negative. Okay, so now that we've gotten this part to here, the next part of our equation is, because this is a division symbol, yeah? It's 2 dots and a line. We can change this expression into fraction form. I should not be writing these equal symbols because that does not make sense in this context. Negative 15 over, this is a bit weird to write, 5 to the power of negative 18 times 2 to the power of 3 down here. Now it is in fraction form, yes? And look at this. Look at this. Look at this.
That's one hell of a 3.
Sam, look at this. Look at this. That is one hell of a 3. Okay. So, due to these both having the same base, we can, and there being powers, we can do a rule where a, let's go a to the power of n divided by a to the power of m, due to them having the same base, it is equal to an minus m. That is one of the other index laws, yeah? You're good? Yes. So, and we can change this to 5 to the power of negative 15 minus negative 18 over 2 to the power of 3. Now, we have separated these and made it a lot less complicated. And also, due to it being another 2 negatives, that means 5 and 15, we make that positive 18 over 2 to the power of 3, yes? Yes. So, now 18 minus 15 is 3. So we have 5 to the power 3 over 2 to the power 3. Now we can't really do anything apart from this. Apart from just making it the big numbers over 8. Okay, so that is the half of this question done.
What are your thoughts, Vasili?
So far, this is a little bit complicated at face value, but if you just break up the question, it becomes a lot simpler. And just solving each part separately, it would become a lot easier to solve. Now, for the second question, I like this question as it is very rounded, you know? First of all, of course, the 0, we make that a 1. So now we have 2 to the power 3 times 3 to the power 3 over 2 divided by 1 over 2 to the power 6 times 3 to the power negative 2 to the power negative 3. Yeah? Look at Samuel Smith. Look at what he's doing. He's playing Monopoly. He probably cheated his answers as well. Yes? No, not Monopoly. Your answers. Now, this next step is similar to the first question, which you should have remembered. So, negative 2, 3, 3, negative 3, negative 2. Yeah? You know what's happening. 2 to the power of negative 6 times 3 to the power of negative 6. Divided by 1 over 2 to the power 6 times 3, and then it's another one of those double negatives. You have to watch out for these. 6. So now, due to another index law, a number, say a to the power of negative n, this is equal to 1 over a to the power of n. I forgot which index law it is again, but it's, yeah, according to Christopher Columbus, it's the 8th one. Wait, your last name's not Columbus. It is Columbus. Chris's last name's Columbus now, by the way. So, we can make this 1 over 2 to the power 6 times 3 to the power 6 divided by 1 over 2 to the power 6 times 3 to the power 6. Now, these two are very similar. However, due to the same thing we did over here, we can... No, we're doing a different thing. Okay? Yeah. So, if it's a fraction divided by a fraction, we can flip the second fraction and turn this into a multiplication symbol, also known as a time symbol. So we can do that. Now we make this times and flip this. Flip it. Flip it like there it is. Like Samuel Smith's going to flip burgers in the future. So 2 to the power 6 times 3 to the power 6 over 1. Now, you may recognize this from my past lessons, but if you have it looking like this, and like a fraction times a fraction, that would equal to, and also since it's times 1, so you can just get rid of that, it would equal to 2 to the power 6 times 3 to the power 6 over 2 to the power 6 times 3 to the power 6. These are the same. So now, obviously, in fact, this is actually the same to this, just in case you weren't keeping up. So, from here, you can already see these are the same, those are the same, so we can just cancel these out. Since everything's cancelled out, it would equal 1 over 1, which, if you have been keeping up with your fractions, is equal to 1. And that is our answers. 125 over 8 and 1. Thank you very much. And
Good job, Vasili.
Samuel Smith, he contributed nothing to this. Chris, thank you, Chris.